Hello, I will be doing video assignment 15 by me, Sebastian Schmedler. So this is asking us to do two questions. The first one is we have to compute an integral. The second one, it's asking us whether a statement is true or false. We're going to do number one because it's number one. So we have to compute this integral. It's the integral from 2 to 5 of 1 over the square root of x minus 2 dx. So if we look at this, we can see that if we were to put in 2, well, here I have a graph of it. We can see that at 2, there's a vertical asymptote, so the line or the equation doesn't exist at that point. So it's going to be kind of difficult to take the integral of it. So what we're going to do is we're going to use a definition from chapter 7. Definition, I have it here. Definition 7.8.5, which says that if f is continuous from a to b, not including a, and it is discontinuous at a, just like here, it's discontinuous at 2, then we're going to say that the integral from a to b of f of x is going to be equal to the limit as t approaches a from the right of the integral of t to b of f of x dx. Okay, so now we're going to apply that definition to our integral here. So we're going to say that the integral from 2 to 5 of 1 over the square root of x minus 2 dx is going to be equal to the limit as t approaches 2 from the right of the integral from t to 5 of 1 over square root x minus 2 dx. Now, to solve this, we first have to solve for this integral here. To do that, we're going to do u sub. So we're going to set u is going to be equal to x minus 2, and du is going to be equal to dx. Then we plug that in. So we're going to say limit as t approaches 2 from the right of the integral of t to 5 of 1 over the square root of u dx. Then we're going to simplify this. We're going to change the, we're going to write this 1 over square root of u as instead u to the negative 1/2, because square root of something is to the 1/2 power, and 1 over that is just going to be negative 1, so we end up with negative 1/2 dx. Then we take the integral of that. So the limit as t approaches 2 from the right, forgot a plus there, so the integral of that is going to end up being 2 square root u from t to 5. And the reason it's that is you add 1 to the power, then divide by that new power, so it's going to be u to the 1/2 over 1/2. So u to the 1/2 is square root of u, and dividing by 1/2 is 2, so 2 square root of u, or is the same as multiplying by 2, I should say. Then we're going to plug our u back in, so we have the limit as t approaches 2 from the right of 2 times the square root of x minus 2 from t to 5. And then we plug in our bounds. So limit as t approaches 2 from the right of 2, and it's going to be square root of 5 minus 2, which is 3, minus 2 times the square root of, we plug in t for x, t minus 2. And then we are going to take the limit of this. So the limit as as t approaches 2 of 2 square root 3 is just 2 square root 3. And if we plug in 2 here for the t, we're going to see that 2 minus 2 is 0, and the square root of 0 is 0. 2 times 0 is 0, so we have 2 square root 3 minus 0. So 2 square root 3 is going to be our final answer. So the total integral, or the integral, the area underneath our equation is going to be equal to 2 square root 3. Alright, so now number 2. Number 2 is asking us to determine whether or not this statement is true or false. So it's saying, if f of x is less than g of x for all x and the integral from 0 to infinity of g of x dx diverges, so the area underneath it would be infinite, then the integral from 0 to infinity of f of x must also diverge. So to do this, I'm going to draw a quick graph just to make it a little easier to understand. So I'm also going to color code this a little bit. We're going to say f of x is red. So that's a little difficult to see, isn't it? And g of x is going to be blue. So g of x is bigger. We'll do that one first. It's blue. So it's going to be, I don't know, we'll say it's that. And then f of x is going to be smaller for all x. So we'll say that. I'll label them. G of x, f of x. Alright, so for g of x to diverge from 0 to infinity, this is going to kind of have to go off this way. Didn't really leave much room, but it's going to have to go off this way. Which would mean it has an infinite area underneath, and then this is saying that because this diverges, then f of x must also diverge. If we look at this, we can see that it's not actually forced to. It doesn't have to if it doesn't want to. So it can go off that way, but it can also just as easily go down and cross the x-axis again, meaning it would have a definite area. So this is false. If this had said instead of diverges, if it had said converges, so that g of x would go down, cross the x-axis again, get us a definite integral, or a definite area, then this other one, f of x, which is always less than it, would also have to converge, yeah, because it would also then be forced to cross the x-axis again. I hope that makes sense. Thank you for watching, and goodbye.